So our next speaker is Asma Ben Abacha, who is a staff scientist at the Lister Hill National Center for Biomedical Communications Division at the U.S. National Library of Medicine, or the NLM, which is part of the NIH, or the National Institute of Health in the U.S. She works on NLP in the medical domain, particular medical question answering.
Thanks, Kyle. Thanks for the also organizers of the workshop, and hi everyone. So I'm glad today to talk about the organization of the challenges and shared tasks in the medical question answering, and to share some of the research insights from these community efforts. So first, I have a quick disclaimer. The views and opinions expressed do not state or reflect those of the US government. In this talk, I will start by presenting the tasks targeted through the organized challenges, the created data sets, and the obtained results and finding. Then I will discuss evaluation methods and other aspects related to community evaluations and shared tasks. So although question answering is one of the oldest AI research topics, medical question answering is historically more recent. I started working on medical question answering in my PhD thesis, where I built a question answering system combining semantic web technologies and NLP methods to retrieve answers to medical questions. The project included several interesting subtasks, such as named entity recognition and relation extraction, but the most challenging part was evaluating the final question answering system because of the lack of relevant data sets. In fact, at that time, and until 2017, I found only one data set that could be used as a benchmark for medical question answering, and it was a corpus introduced in 2011 for evidence-based medicine summarization. So this is why I organized several challenges on medical question answering and related tasks in the past 3 years. The first challenge was on medical question answering at the track 2017 Live QA track. The track included 2 tasks on open domain and medical question answering. I organized the medical task in collaboration with Eugene Agerstein, Yuval Pinter, and Dina Demir-Frischman. The task addressed answering consumer health questions received by the US National Library of Medicine. We provided both training question and answer pairs and test questions that we manually annotated with references and additional annotations, such as the main topics and the question type. The Live QA medical competition was a platform to apply state-of-the-art models of that time on medical question answering. In particular, several deep learning models were tested, including attentional encoder-decoder networks, LSTMs, and CNNs, and participants used both domain and medical data sets for training. The best participating system relied on similar question matching for the question answering task, in contrast with the other systems which used classical question answering approaches based on information extraction and answer retrieval. The results also highlighted the gap in performance between the open domain and the medical domain when the same participating systems were applied to both medical and open domain tasks. This was likely due to the need for larger medical data sets to support deep learning approaches in dealing with the linguistic complexity of consumer health questions and the challenge of finding correct and complete answers. In 2019, we organized the Medica Shared task at ACL BioNLP with Chaitanya Chivade and Dina Demir-Frischman. The challenge focused on 3 tasks: natural language inference, NLI, recognizing question entailment, RQE, and question answering. There were 3 motivations behind Medica. First, very few works highlighted here in red in the figure addressed entailment and inference in the medical domain before Medica, compared to thousands of papers in open domain. Second, the use of entailment and inference in question answering was not yet well investigated in both open and closed domain. And the third motivation was from my previous experiments that showed that question answering approaches based on RQE can outperform other approaches. In particular, our RQA-based question answering system achieved a relevance score of 0.82 when the best score achieved at the MED LRQA challenge was 0.63. The competition attracted 72 participating teams from both the industry and academia, and 20 working note papers were published in the proceedings of the ACL BioNLP workshop. Medica 2019 confirmed the added value of using textual inference and question entailment in question answering, highlighted the strength of multitask learning, transfer learning, and data augmentation methods, and also showed the power of new architectures and models such as MTDNN in medical question answering. A post-challenge round is now open if you are interested. The third challenge is VQA Med, and this is one of the very early efforts in VQA in the medical domain. I organized VQA Med with Sadid Hassan, Vivek Delta, Dina Dubner-Fushman, and Henning Müller in 2019 and 2020. For the 2019 competition, I targeted 4 categories of questions, which are modality, plane, abnormality, and organ system, and created the questions and answer with different degrees of difficulty. The first 3 categories can be addressed as classification tasks, and the 4th category, abnormality, presents a text generation problem. 17 teams participated in the VQA Med competition. The best blue score was 0.64, which is substantially better than last year's best performance of 0.16. This good performance is partially related to the newly designed data set, but also to the different approaches that have been applied, such as hybrid methods, combining classification and answer generation. The accuracy scores by category also showed the effectiveness of the participating systems in answering the modality, plane, and organ questions, but not questions about abnormality. This year, we focus on the more challenging questions about abnormality, and we include a new task on visual question generation. Both tasks, VQE and VQG, require a challenging bridge between NLP and computer vision in addition to the specificities of the medical domain. 11 teams participated this year. Their working note papers will be published in September with the CLE conference. So for the VQA and VQG tasks, state-of-the-art models in NLP and computer vision have been applied, as well as new approaches focusing on abnormality questions and images that have been proposed, dealing to very good performances. These results are very exciting, knowing the potential applications of these 2 tasks in the medical domain. In particular, visual question answering system can be used to support clinical education and clinical decision-making, and visual question generation system can be used to build dialogue systems where the generated question could be used by the patients to start a conversation with their doctors. A core aspect in organizing the challenges and shared tasks and also ensuring an incremental scientific progress in the relevance of the evaluation metrics. The results presented here are from our first work paper on VQA, where the scores of the manual evaluation of the answers retrieved by different VQA models on the VQA dataset were very different from the blue scores. For open-ended questions, the ranking of the system, of the different systems was also different, and the best system based on the blue score was the worst system based on the manual evaluation. For another task, which is abstractive question summarization, a manual evaluation of 10% of the generated summaries gave scores and rankings different from the scores and rankings of Rouge 1. However, other metrics such as accuracy, MAP, and MRR for question answering, for example, are more correlated with human judgments and provide a relevant platform to rank systems, even if the difference between their exact values for 2 specific systems can be misleading because of several factors, such as the incompleteness of the benchmarks and the annotator's bias. Still, the major issue remains the less reliable ranking of existing evaluation measures for text generation tasks. So challenges and shared tasks have similar benefits, such as discovering the range of potentially hidden obstacles and putting system performance in context. For example, agreement levels between human annotators are telling of the difficulty of a task and of the level of performance of automated systems. They also offer useful gold standard corpora training data and use cases, and they help building strong research communities. But there are at least 3 aspects that need more investigation: efficient and suitable evaluation methods and metrics, important newly identified subtasks that need to be resolved first. An example here is the RQE task for question answering, and also designing and creating beta training and testing datasets, which implies defining what is a good training and test set for a specific task and application. One last important aspect is the need for multidisciplinary efforts and collaboration, and also supporting more workshops and conferences such as TREC and CLE that continue to contribute a lot to the research and evaluation efforts. And thank you all for your attention, and I will be happy to answer your questions.
Awesome. Thanks so much, Asma. Oh, looks like we have plenty of time left then. We'll give people a minute to type in questions for Asma into the Zoom chat. So there was one question. Yeah. Lucy asks if you can talk a bit more about consumer health question answering.
The method that we use, or the shared tasks organized related to the to consumer health question answering?
Seems like it's emphasizing the goals of the NIH around this.
The goal? Okay, so thanks, Lucy, for the question. So the goal is to build a system that is able to support the customer service and the NLM in answering the questions that the NLM receives every day. And we built a first question, consumer health questions, called Chica, which is available online at chica.nlm.nh.gov. And but we continue also, so the system is able to answer, I think, a wide range of questions, medical questions, but we continue to investigate and improve the system by working on summarizing the answers, on analyzing more questions and improving the answers for several question types, and adding maybe more images or videos related to the answers, and to improve the answers. I hope I answered the question.
Sorry, please put the chats in the public, not directly to me. There's a follow-up question around, do you know if there are any interesting distinctions between the domains consumer versus healthcare?
Yeah, so so for consumers is more questions about, of course, asked by patients or their families. So we all are health consumers. So for healthcare, if it means, I think it's larger. It's a larger users. So it could be health professionals. So yeah, medical experts, or so different. I think here we'll have more types of questions that could be asked by health professionals, for example, or all actors related to the healthcare system.
In addition to that, do you think the data from one can be leveraged to improve the performance in the other domain?
Data from what, sorry?
From the clinical domain and the consumer domains, can they be used to help each other?
So what actually, for the medical shared task last year, for example, for the NLI data set and NLI task, the data was clinical data, so clinical sentences extract from I forgot the name of the data set, but this is a clinical data set, and the results showed that it's helpful for the questiontainment task that uses consumer health questions. So yes, I think it's also for, I think, all the experiments that I did on questiontainment since 2016, I usually use the collection of questions asked by family doctors. So these are clinical questions, and they always help and improve the results when I use them for training the models for consumer health questions.
Awesome. Thanks so much for the talk, Asma.